Yeah, in this class, I would like to teach you image formation by concave mirror. Image, images, formation, image formation by concave mirror. So this is very important for the 10th examination, like 10th examination point of view. And I make one table here so that we can understand very easily. So I make table here, the first serial number, and location of object or position of the object, or position or location. So I place the object different locations here, and the position of the object can place different positions. Next, image information. So after placing the object at different locations, we need to find out the what is the location of image. What is the location of? Where is the location of image? Location of image. Location of image, and the size of image. What is the size? Bigger or smaller? Size of image. Size of image. Next, nature of image. Nature of image means is it a real image or virtual image? So you make table like that, so that we can understand the concept very easily. So this is my entire table. This is serial number one, serial number, and position of the object. This is the entire image information. In the image information, we have three columns. One is the location of the image. Where is the location of the image? So this is a location of image. This is the size of the image and nature. Okay, the first one here. So I place the object at a infinity. So image at a infinity. Image at a infinity. So I place the object at infinity. Then we have to find out what is the location of the image, what is the size of the image, what is the nature of the image. For that here, I can do the ray diagram. So for ray diagram at infinity. At infinity, so object is at infinity. Then so we need to find out the what is the location of the image. So I find, so this is the entire information about the concave mirror. So draw the concave mirror. This is my concave mirror. Okay, and now bulged surface should be silver coated. Bulged surface should be silver coated, and which is having the pole P, and which is having the center of curvature C. And if you join the center of curvature and pole, and this line is called as a principal axis. This is a principal axis. Principal axis. Okay, next one. So now we need to find out the, and so generally we can assume that if the object is in infinity, so we can assume that here all rays close to each other and they are parallel. That means here if you represent like that here, so all rays are parallel means here that object is at a infinity. So these are all rays coming from the object which is at a infinity, which is at a infinity. These are all rays are incident rays which are coming from the object. Okay, and you know that here one of the rule for the image formation by spherical mirrors, if the all rays are parallel to principal axis of reflection, they pass to the focus. So this is the focus means exactly midpoint of the center of curvature and the pole, and this is the after reflection. This is the first incident ray. So after reflection, it passes through the focus, and this is also focus to the focus, and this is also focus to the focus, and this is also focus to the focus. Okay, these are all reflected rays. These are all reflected rays. So all reflected rays here they are meeting. So they are meeting one point. They are meeting one point. That point is a focus here. So this is a, you know that here the point of intersection of all reflected rays is called as image. So image is formed at a F. Okay, this is the first image location when you place the object at a infinity. Okay, coming back to the table here. Coming back to table. So if you place the object at infinity, that what is where is the location of the image? The location of the image is here at a focus of the mirrors focus. Next here Where is the what is the size of the image? So that is a point size. That means here highly diminished. So it's very very small here. That's why we can call here highly highly diminished, highly diminished, highly diminished image, highly diminished image. Next, what is the nature? Nature means here it should be, it is a real and inward, because this should be real. Real means they are all reflected rays are meeting. Really meet, that's why it is real image. Every real image, every real image that should be inverted image. So real and inverted image, real and inverted image. This is the first case number one. In that here, object is placed at infinity. And go for the next one. Now place the object. Now we can move the object towards mirror. That means here, so we can place the object behind the center of curvature, behind the center of curvature. So I'll draw the second ray diagram, second point here. So object behind the center of curvature, behind the center of curvature, see center of curvature. So again draw the concave mirror. This is concave mirror, and this is a pole, and this is a center of curvature, and join the center of curvature and pole. That is called as a principal axis. Principal axis, and the midpoint of the center of curvature and pole is your focus. Okay, now I place the object behind, so behind the center of curvature, that is the height of the heights. That means the object which is having some height. So this is a, so I can take this is a and this is a B. The height of the object is AB, otherwise the height of the object is AB. Okay, we know that here. Now I want to find out the what is the image of this total object here. To find the image of this object here, I can take top point and bottom point. To find the top image of top point here, we can take two lines, two incident rays. So for example, I can take here, this is the first ray which is incident on the mirror, and second ray I can take here which is passing through the center of center of curvature, center of curvature. Okay, yes. So you know that here, so this is a ray which is parallel to principal axis, the first incident ray which is parallel to principal axis. After reflection, it passes through the focus. After reflection, it passes through the focus. This is a reflected ray for the first incident ray. And you know that here one more incident ray which is passing through the center of curvature. So we know that here after reflection, which is reflected back and which follow the same path. This is a reflected ray also. This also, it always follow the same path, but it is a reflected back. So this is, so they are meeting at one point. That point is here. So location of the pop point. Okay. So next one. Similarly, so you know that if you take this point, so definitely there is a formation of image here. Like that, B is a put of the perpendicular to the entire principal axis. Definitely, B also forming on the principal axis. So this is a uh, location of the image. That means here, where is the location of the image, which is exactly between the center of curvature and the focus. Okay, what is size here? Size, when you compare with the previous case here, so here the size of the image increased. Increased means here that is a diminished, highly diminished, next year diminished. So, and what is the nature of the image? Real, and real means here, so it is always they are all reflected rays are meeting at one point, really meet, all reflected rays really meet, that's why the real image. So every real image, it is inverted. So again I go back to the table. So first to I complete all the cases here, then after I go for the table. So in this case here, so at a beyond, if you place the object behind C and image location, image at a in between center of curvature and focus. Next, and what is the size here? Size is here diminished diminished image. So if you compare with the previous case here, so there is increment of size of the image is increased. That's why first case highly diminished, next year diminished. Okay, next one. Go for the next. What is nature? Nature is here real image, because here all reflected rays are real image. That's why real image, and inverted image, because here which is reverse. The orientation of the image which is opposite to the orientation of the object. That's why it is inverted image. So inverted image, real and inverted image. Yes, go for the next position, the position of the object. Third case. Now we need to move again towards mirror. Now I place the object at the center of curvature. First draw the concave mirror, and this is my pole, and this is a center of curvature. If you join the center of curvature and pole, this is my principal axis. Principal axis. Now I place the object at a center of curvature, and this is my pole. Now we create two rays here, two from the top point and two from the bottom point. So I can take two. One is parallel to principal axis. After reflection, it passes through the focus. So after reflection, it passes through the focus. This is the reflected ray for the first incident ray. Next, one more ray we can take here. That ray is which is coming from the same point. So this is a passing through the focus. So we know one rule. Second rule is there. The ray which is passing through the focus after reflection, they become parallel. They become parallel. So they become parallel. They're meeting at a here exactly at this point. So this is a so image of top position. Image of top position, and B is the put of the perpendicular exactly at the center of curvature. Means here, if you compare it here, here size of the image should be is equal to size of the object. Again, image nature is real and inverted image because the orientation of the image which is opposite to the orientation of the object, and also which is exactly at the center of curvature. So here on center of curvature, so object is at a C and image also at a C. Therefore, image are also on center of curvature. And one more thing here, size is increased. Size is same as that of the object size. So size of image is equal to size of object. Size of object. Both sizes are equal. Next, nature, real and inverted image. Real and inverted image. Real and inverted image. Next, fourth case. Yeah, fourth case. Now I place the now in the previous case I place at the center of curvature. Now I place the object in between the center of curvature and focus. So this is my concave mirror. Concave mirror, which is the principal axis, which is passing through the pole and center of curvature, and this is a focus of the concave mirror. Now I place the object in between the center of curvature and the focus. Same thing, this is A and B. A and B. Now take the two rays from the A. One is a parallel to principal axis. After reflection, it passes through the focus. This is the reflected ray. And one more thing here we can take, which is passing through the focus. And after reflection, they become parallel. Sorry, they become parallel, and all previous reflector and this reflector they are meeting at a one point. That point is this one, a dash. I can take this is a dash, and B is put out the perpendicular. Draw the put out the perpendicular from the principal axis, so that this is my image of AB. So this is I can take B dash. So therefore here size of the image increased when compared to the previous. So where is the image location? Here I place the object in between the center of curvature and the focus, C and F. Okay, C and F, and the image beyond C. So image is formed at beyond C, beyond center of curvature. And what about the size here? Size is increased. That means size is uh, enlarged. Size is enlarged. Size is enlarged. What about the nature? Real and inverted. Real and inverted image. Real and inverted image. Okay. Next one. Now previous case we place the object in between the focus and the center of curvature. Now I place exactly focus at F, at a principal focus. At principal focus. Again draw the concave mirror and locate the pole and center of curvature, and draw the principal axis which is passing through the center of curvature and pole, and locate the principal focus also. Now I place the object on the focus. Now again take the two rays from the top point. So one is from the parallel to principal axis. After reflection, it passes through the focus. This is a reflected ray. Next, one more I can take here. So that is which strikes the pole. Strikes the pole. This incident ray. After reflection, they are reflected back symmetrically. So they are like that. So they're going like that. So it means here the all rays they are all. So we assume that here these all rays meeting at infinity. That means here image at formed at infinity. So image at infinity, image at infinity. What about the size? Highly enlarged. Size is bigger. Highly enlarged image. Enlarged image. Highly enlarged image. Next, what is nature? Real and inverted image. This is a real and inverted image. Okay. Next, last case in this. So that is if you place the object in between the, yeah, 6 1. So I place the object at between focus and pole. Focus and pole. So again draw the concave mirror. This is my concave mirror, and this is my principal axis. And this is a pole. This is a center of curvature. This is my focus. Now I place the object in between the focus and pole. Again take the two rays. One is parallel to principal axis. After reflection, it passes through the focus. So it passes through the focus. Next, one more ray I can take here. That ray is here. So which is strike the pole. After reflection is symmetrically reflected back. Symmetrically they are reflected back, and these are, if you see here from this side here, so these two rays coming from this point, these two rays coming from this point. So this is a position of the top point. So if you B is this is the A position, and if you draw the put of the perpendicular, the exactly image formation is like that. This is A dash and the B dash. Yeah. So what is where is the location of the image? The location of image is behind the mirror. Behind a mirror. Behind the mirror. And what is the size? What is the size of the image? Enlarged. Enlarged image. It means enlarged size of the image greater than the size of the object. Next, what is nature? Nature means it is a virtual image, because here is a point of intersection of extended reflector. That's why it is a real virtual image. Virtual image. Virtual image. Every virtual image is a erect. Erect means here the orientation of the object, which is same as the orientation of the image. That's why it is called as erect image. So these are the 6 cases we need to remember. So here again I fill the table here so that we can understand. Yeah, second point. What is second here? So we place the object infinity over beyond C. So if we place the beyond C, beyond C, where is the location of the image? The location of the image from the focus, that is between the center of curvature and focus, C and F, C and F, C and F. What is the size here? Size is increased. So first is highly diminished, next is here diminished, diminished image, diminished image, diminished image. What is the nature? Real and inverted image, real and inverted image, real and inverted image. Yeah, next point. So now I place the object here. Just now we have seen that is behind C is over at the C, at center of curvature C, and the image also at C. In that case here, what is size of the image? So which is same as that of same as that of same as that of size of object, size of object, size of object, size of object. Okay, so what is the nature? Real and inverted, real and inverted, real and inverted. Okay, next one. Fourth one. Now move the object towards mirror after C between C and F. Between C and center curvature and focus, and image should be moving from away from the mirror, that is after C, that is beyond C. The image is at beyond C, and size must be increased, that is enlarged image. Next, what about the nature? Real and inverted. Real and inverted image. Real and inverted image. Next, fifth point. Now C and F is over. Now towards we move towards the uh, mirror. The fifth one is here. The fifth one, C and F is over at a focus. Yeah. At focus, where is the location of the image? The location of the image. Focus. At focus, the image. There's a image is here at infinity. So image at a infinity and highly enlarged. So image size is a highly enlarged, highly enlarged, highly enlarged, and real and inverted, real and inverted, real and inverted. Yeah, last case, sixth case, very important here. And if you place the object between the focus and pole, and the image location is beyond mirror, so mirror, beyond mirror, that is beyond mirror. And what is the size? Size is enlarged image. Enlarged image. That means size of the image is greater than the size of the object. That is enlarged image. What about nature? Nature is virtual and erect. Virtual and erect. So from this we can say that here. From this we can say that here. By using concave mirror. By using concave mirror. So by using concave mirror, so we can form. So by using concave mirror, concave mirror, we can form real image, real image as well as a virtual image, and also we form the different sizes, small diminished, highly diminished size, and same size of that object size, and also greater than the size of the object also. We can form all size of the images. Okay, small, big, and greater than the object also we can form. Okay, and also in the virtual, if you observe here, in the virtual case here, that is we definitely we should place the object between the focus and pole. If we place the object between the focus and pole, that image formation is virtual image which is behind the mirror. So one of the application for the concave mirror is here, and for example, I can say here, I can take go back to the next slide. Yeah, right. Right. This is about the concave mirror. So if we see applications of concave mirror, applications are very important for the exam point of view. Applications where we can use this concave mirror. So we can use concave mirror, for example, in the headlights, for example, torch lights. For example, if you observe the torch light here, and this is a torch light mirror, that is a concave mirror. Exactly place the torch light here exactly at the focus of the mirror, and whenever it instant all the lights on the mirror and they become parallel. That means here We could travel, right? It can travel. So it can travel so much distance. Here is also one of the application of the uh, concave mirror. So we are using in a torchlights, 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 and vehicle headlights also. Vehicle headlights, vehicle headlights, and vehicle headlights also we're using vehicle headlights, vehicle headlights, and dentist also can use that to see the small teeth. Dentist also use the that concave mirror, and also ENT doctor can also use it. And one more application, solar cookers, solar solar cookers, and use this type of concave mirror. This is the application of the concave mirror. Okay. Next class we will see the image formation by convex mirror. Then after we see the application. Then after we'll discuss the refraction of light. Okay. And thank you. And thank you very much.